Dear student, in previous session, I was discussing regarding the how to convert the block diagram, given block diagram into signal flow graph, and then applying the Mason's gain formula, find the overall gain of a system. In today's session, I'm going to discuss how to convert the given electrical network into the signal flow graph, and then how to find the overall gain system by using Mason's gain formula. The first step is to first convert the electrical network into the signal flow graph, and then we go for applying the Mason's gain formula. We can easily find out the overall gain. Overall gain means V naught of S divided by VA of S by using Mason's gain formula. The first step, I'm going to explain how to convert the given electrical network into the signal flow graph. What are the steps involved in converting the electrical network into the signal flow graph? Is we go for writing the first we need to write the differential equation governing the system, and then take the Laplace transform. Then take the Laplace transform for the given differential equation. Then we will get the algebraic equation. By working knowledge of the system, we should identify which are the constant and which are the variables in that particular equations. Usually variables are assigned to the variables. For variables, nodes are assigned, and also the branch means the branch carries the branch. For the branch, we go for assigning the transmittance or gain. Usually constants are the constant of the equations denotes the overall gain of the system, or transmittance of the system. Here, now by working, first I need to understanding before writing signal flow graph for the given electrical network, we should understand working knowledge of the system is very important. We should, when I look at the circuit, which is the input, by working knowledge of system, we should identify which is the input, which is the output, and which are the intermediate variables, intermediate outputs. Therefore, by working knowledge of this particular electrical network, when I apply the VA of T, immediately I1 of T starts flowing. When I apply the VA of T, due to the input VA of T, I1 of T is generated, and thus this particular mesh, I1 is this particular mesh. Due to the I1 of T, V1 of T is generated. Due to the V1 of T, I2 of T starts flowing in this particular mesh. And due to the I2 of T, the V naught of T is obtained. This is the working knowledge of the system. In order to understanding the working knowledge of the system is very important, because while writing, we should identify which are the input and which are the output. Here, which is the input? V of T is the input. V naught of T is the output. Now these are the output. Now immediate output, when I apply the V of T, the immediate output is I1 of T. I1 of T. Due to the I1 of T, V1 of T is generated. Now when I apply VI, I1 of T, I1 will get current I1. Due to the current I1, the node voltage V1 is generated. Due to the V1, node voltage I2 is generated. Due to the I2, V naught of is obtained across the inductor. Therefore, now for the first section, which is the input, the VA of T is the input, I1 of T is the output. Therefore, we go for, in the first step, find the I1 of T. First, we need to find the I1 of T, and then we go for finding the V1 of T. Then we go for finding the I2 of T. Then we go for finding the V naught of T. These are the I1 of T, V1 of T, I2 of T, V naught of T are the represents the differential equation of this particular electrical system. Then we go for converting those into the algebraic equation, and from working knowledge of the system, and write the SFG for equation, and then interconnect overall equation, interconnect the various sections that gives the overall signal flow graph of the given electrical system. In the first step, I should calculate I1 of t. Now, what is I1 of t? I1 of t is nothing but the current through the resistor. This is the current through the resistor. I1 of t is the current through the resistor R1. Therefore, the current through the resistors can be calculated by difference in voltage, the input voltage V of t. This particular node voltage is V1 of t divided by current V by R. Therefore, difference in voltage divided by R. Therefore, this can be expanded like this: V1 1 by R into VA of t minus 1 by R1. Again, 1 by R1 into V1 of t. Then automatically we will get by taking Laplace transform, I1 of s is equal to I1 of, when I take the Laplace transform, upper lower case letter becomes upper case letter. Laplace transform of the I1 of t is the I1 of s. So therefore, similarly, Laplace transform R1 1 by R1 is a constant. What is the Laplace transform of V of t and VA of s? Usually, lower case letters are used for time domains. Uppercase letters used for the frequency domain, the Laplace domain. And not uppercase, we go for using the S domain. When I take the Laplace transform for the VA of t, then automatically it becomes the VA of s minus 1 by R1 into V1 of s. This is the equation. This is the algebraic equation. When after taking the Laplace transform, we will get the algebraic equation. Now, by working knowledge of the system, in this particular equation, which is the output? The I1 of s is the output variable. Now, these are the input variables. VA of s, V1 of s, the output variables. Therefore, I should write which is the input variables are here. I go for writing the three nodes. Three variables here. That is what we need to write down the three nodes. Three nodes. I should write the three nodes. So here, this is the output. This is the input. And also this is the here. This is the VA of s. This is the VA of s. Now, what is the output of the branch? Any branch. Output of the any branch is a directed line segment used to connect the nodes. The branch is a directed line segment used to connect the nodes. When I apply the, suppose I want to calculate, this is the B, suppose this is the A, the gain is, suppose the gain is equal to, suppose the gain is equal to C is the gain, then the K is a gain, then what is the output? B is equal to input A into this gain K is equal to A into K. That is what, similarly, we go for writing here also. Now, this is the output node. The output, the signals at the output node is equal to sum of the incoming signal. So, therefore, I1 of s is equal to, what is I1 of s? 1 by R1. 1 by VA of s into 1 by R1. This is the 1 by R1. This is 1 by R1. This is 1 by R1 plus 1 minus 1 by R1. V1 of s into minus 1 by R1. V1 of s is equal to, this is 1 minus 1 by R1. This is minus 1 by R1. Now this is the, here the signals at this particular node is equal to sum of the signals from this particular node and this particular node. Now these are three variables there. Here V1, VAE and I1. Therefore, we need to write the three nodes, assign the variable to the nodes. These are the variables. So which is the output variables? This is the output point. Therefore, assign these variables. These are the inputs. So here, when I apply when the signal V of S pass through this particular branch, this is multiplied with this. Therefore, this quantity will get plus again when I this multiplied with this, we will get this quantity. Likewise, we need to construct. This is the signal flow graph of this particular equation. Or this particular section. In next session, I'm going to, for the next section, which is the input, I should calculate the V1 of t by considering the I1 of t is the input. In the next section, output of the current section goes to the input for the next section. In the next step, and go for calculating V1 of t. V1 of t is the output, I1 of t is the input for the next section. In the step 2, I'm going to calculate the V1 of t. In step second. In step 2, we go for calculating the V1 of t. The step 2, we go for find the V1 of t. Now, what is V1 of t? V1 of t is nothing but the voltage across the capacitor C. Now, what is the voltage across the capacitor equation? 1 over C into integral I1 of t minus I2 of t into dt. Therefore, for this equation, take the Laplace transform. After writing the differential equation, take the Laplace transform. By take the Laplace transform, now the V1 of t becomes V11 of S. V1 of S is equal to 1 over C into integral of dt. What is the Laplace transform of? Laplace transform of integral dt is equal to, what is the value? Is equal to 1 by S. Laplace transform of the integral dt is equal to 1 over S. Therefore, I am writing here 1 by C as it is. So, integral dt 1 by S. So, then Laplace transform of I1 of t becomes I1 of S. So, and Laplace transform of I2 of t becomes I2 of S. So, and then now after taking Laplace transform, we go for multiplication. This term is this. The V1 of S is equal to 1 by SC into I1 of S minus 1 by SC into I2 of S. So now this is the input. Oh, this is which is the output. Oh, now this is the output. Correct. In correct section, this is the output. Oh, these are the input. Oh, now the previous output, the output of the previous section. The first section is the input for the current section. Oh, I1 of t is the input. I1 of t is the input. I1 of S is the input. And I2, V1 of S is the output. So, surely there are three variables here. Here there are three variables in the algebraic equation, I1 of S, so I2 of S. So we go for writing the three nodes. For these three nodes, assign the variables. Which are the input? This is the here the output. This is the output node. Now this is V1 of yes. Now what is this? Here, what I should write? The input is, this is the output of the previous stage is I1 of S. Output of the previous stage is, this is the output. Oh. Now what I2 of t? I2 of t is the output of the next stage. Oh, then I should write, this is the I2 of S. Go for taking the output from the next stage. Oh, now this is the, what is the value of S? So I1 of S must be multiplied by this. Then you will get the, this is the 1 by SC. Here I should write 1 by this value. Here the, what is the signal at this particular node is equal to minus 1 by S. I should write SC. Here I should write minus minus 1 by SC. This is the minus. Now, what is the signal? This particular node is the input, sum of the input signal. Therefore, input at this particular node is equal to sum of the input at this particular node, I1 of S, I1 of S into 1 by S plus I2 of S into this transmittance. So, when the signal I1 of S is flowing through this particular branch, then automatically I should multiply it with the gain. Now, these are the constant. So, these are the variables. So, constants are assigned to this branch. The gain or transmittance of the branch. 1 by SC is the transmittance or gain or transfer function of this particular. Here there is a minus 1 by S is the transfer function of this particular branch. The signal at this particular node is equal to sum of this. Here this is the input into the transfer function, that is the plus I1 of S into 1 by S. Then you will get this particular equation. The next section, the output of the current section is V1 of S. So goes to the input for the next section. No? Therefore, by considering V1 of T, go to the next section. No? When I apply the V of T, I1 of T obtained. Due to the I1 of T, V1 of T is obtained. Due to the V1 of T, after obtaining V1 of T, I2 of T is we need to calculate. This is the I2 of T. I2 of T is the output of the next stage. So next step, I should calculate. In step 3, I should calculate the I2 of T. In step 3, we go for calculating the I2 of T. In step 3, we go for calculating I2 of T. Now in previous section, output of the previous section is V1 of T. Output of the current section, output of the previous section is the input for the current section. Now, when I apply the V1 of T, what will be the output of I2 of T? When I apply the V of T, I1 of T is generated in this mesh 1, and due to the I1 of T, V1 of T is the next output, and next output is I2 of T. Therefore, I2 of T is calculated by using, what is the I2 of T? I2 of T is nothing but the current through the resistor R2. Current through the resistor R2. Now, what is the current through the resistor? The current through the resistor is equal to difference in this node voltages, V1 of T and V1 of S, that I have written here. I2 of T is equal to current through the resistor R2. Therefore, this difference in voltage, this particular node and this particular node divided by R2 V by R. Then by taking Laplace transform, what is the Laplace transform of I2 of becomes I2 of S. I2 of S is equal to 1 by R2 as it is. So what is V1 of T? Laplace transform of V1 of T is V1 of S. So minus 1 by R2 as it is. Then Laplace transform of V1 of T, V0 of T is equal to V0 of S. So now this is the equation. From after taking the Laplace transform, from this equation identify which are the input variables. Which is the input variables? Output is the I2 of S, the input output variables. V1 of S is the, because due to the V1 of T, I2 of T is generated. Therefore, this is the input and this is also input. Therefore, the 1 by R2 is the transfer function. The output of the any branch is equal to the product of the input. So here I should write the now diagram, signal flow graph for this particular equation. Therefore, output of the any node, the output here, I should write what is the output of I2 of S is the input into the transmission, into the transmittance. So, transmittance are, this 1 by R2 is a constant assigned as a transmittance or gain of this particular branch. So, a variable V1 of is assigned to the node. Now this is the input. Now this is the one of the input. We will get this term. In order to get this another term, I should write another variable, another node, create, assign this to the V0 of S. I showed this quantity. Now this is also input for this particular node. Now what is the here? The gain is 1 by R2. The gain of this particular branch is 1 by R2 minus 1 by R2. Now what is this? What is the signal at this particular node? Is equal to sum of this signal and this signal. Therefore, while passing from the signal through this particular branch, this transmittance multiplied. Therefore, V1 of S into output of any node is equal to input into this transmittance. So similarly, plus this input into this transmittance. So then you will get this particular term. Now this is the SFG for this particular equation. In the next step 4, we go for calculating the V0 of t. When the current I2 is generated or flows in this particular mesh, mesh second, then automatically the output voltage V0 of is generated at this particular node. Now what is V0 of t? V0 of t is nothing but the voltage across the inductor L. That can be calculated in step 4. Step 4, we go for calculating the voltage across the inductor L. In step 4, we go for calculating the voltage across the inductor V0 of t. Now, how to calculate V0 of t? Voltage across the inductor L. Therefore, the voltage across the inductor L is equal to L into di2 by dt. This is the standard relation. The voltage across the inductor is equal to L into di by dt. Here I2 is present, therefore d by dt of I2 of t. Now if I take the Laplace, by taking Laplace transform, V0 of t becomes V0 of s, L into s into I2 of s. So for d by dt, Laplace transform of d by dt is equal to what? Is equal to s. So integral of d by dt is equal to 1 by s. So is equal to standard relation. Now, by taking Laplace transform of d by dt, we'll get s. So the Laplace transform of I2 of s, I2 of t becomes I2 of s. So from this particular equation, from working knowledge of the system, identify which is the input. The input is output of the previous stage. The output of the previous stage is the I2 of t, and the current stage output is the V0 of s. So is the output. So therefore, there are two variables. So I2 of s is the one variable, V0 of s is one variable. We should create the two nodes. Two variables or two nodes. So which is the output variable? So here V0, this is the output variable. So which is the input variable? I2 of s. So here the branch, this is called as a branch. In order to connect these two nodes, go for collecting now what is the gain of this particular branch? Is the transmittance. So this is the transmittance to S into L or L into S. So it's the transmittance of this particular branch. In the next section, in the next step, we go for integrating the various signal flow graph. I have drawn from step 1 to step 4. We go for integrating, then we will get the final signal flow graph for the given electrical network. In step 5, we go for integrating the different section, and then we will get the overall signal flow graph of the given electrical network. In step 5, I am go for writing overall signal flow graph of the network. How to write the overall signal flow graph means you need to create the nodes for the input nodes, input variables, output variables, and also the intermediate variables. Now, how many variables? These are the 5 variables. We need to create the 5 variables and assign the variables to these nodes. So this is the input variable V of t, V of s. So I1 of t, Laplace transform I1 of s. So this is the V1 of t, Laplace transform of t, V1 of t becomes V1 of s. So there are 5 variables. We need to create the 5 nodes and assign the variables to these nodes. And what is the value of when I apply the VA of t, then what will be the I1 of t? I1 of t is the current through the resistance R1. Therefore, this is the section derived in the step 1. Now, this is the value. This is the section derived in. This is the section derived. I1 of s can be calculated by or derived. This SFG can be derived in section step 1. This is the now this can be integrated with another section. The output of this section goes to the input for the next section. Therefore, now what is the output of the next section? Is equal to this is the output. This is the input. Now this section is derived in step 2. Now this is the V1 of S, is the voltage across the C. Therefore, here I should write what is the value this gain or S into C minus S into C here plus S into C. Similarly, I2 of S is the resistance R2. Therefore, here I should write 1 by R2. The output of the current section goes to the output of the previous section goes to the input for the current section. This is the 1 by R. Now, what is V0 of S? So, the voltage across the inductor L. Therefore, here there is a branch. I should write here I should place the value S into L. Now, this is the overall signal flow graph, the given electrical network. Given electrical network. This is a way. This is a way we go for constructing the signal flow graph for the given electrical network. In next step, what we should calculate? We should calculate the transfer function of this particular signal flow graph using Mason's-Kane formula. Now we need to apply the Mason's-Kane formula for this particular signal flow graph. Now, what is the transfer function? We need to calculate V0 of S divided by VA of S is the transfer function or overall gain of this particular signal flow graph. This particular signal flow graph going to explain in next step. Once we draw the signal flow graph for the given electrical network, we should how to calculate the overall gain. The overall can be calculated by using Mason's-Kane formula. The overall gain or transfer function is equal to V0 of S divided by V of S. This can be calculated by using Mason's-Kane formula. The Mason's-Kane formula states that the transfer function V0 of S divided by V of S is equal to 1 over delta, the sum of Pk into delta K. Now, K, what is K? K means number of forward path in the graph. So, here, in this particular graph, there is only one forward path. Therefore, K is equal to only 1. Therefore, K is equal to 1. Therefore, this is equal to 1 by delta P1 into delta 1. In the next step, we need to calculate, in order to calculate the transfer function, we need to calculate P1. P1 means gain of the forward path plus 2. What is delta 1 now? And delta we need to calculate it in next step. and then substitute, we will get the overall gain of the system. After writing the formula for calculating Mason's gain formula for calculating the overall gain of the system, the next step we need to identify the forward path from the signal flow graph. There is only one forward path. There is in this particular signal graph, there is only one forward path. Forward path means starting from input node, ends at the output node without crossing any node more than one. So it starts from VI node, go to the I1 node, V1 node, I2 node, V naught of S. This is the first forward path. The gain of the forward path 1 is denoted by P1. Now what is the P1? Gain of the forward path is nothing but it is the product of the branch transmittance. It is the product of these are the branches. So therefore we need to multiply 1 over N into 1 over SC into 1 over R2 into SL. Therefore this S and this S gets cancelled. Therefore the value of the P1 is equal to L divided by 1 R1 into R2 into C. This is the first forward gain, the gain of the first forward path. In the next step, we need to calculate now what is the step means? In the next step, we need to identify the number of loops in the signal flow graph and then find the loop gains. That is called as the individual loop gains. Is the next step of calculating the overall gain of the system. In this particular step, we go for calculating the individual loop gains. In order to calculate individual loop gains, we need to identify how many loops are present in the particular signal flow graph. There are 3 loops. After observing in the graph, there are 3 loops. L1, L2, L3 these are the 3 loops. So this is the one loop, this is another loop, this is the other loop. We need to calculate the gain of the loop 1, gain of the loop 2, and gain of the loop 3. The gain of the loop 1 denoted by P11. What is the loop? The loop is nothing but is a closed path starting and closing at the same node. Starting and closing, starts at the starts and ends at the same node. What is the definition of the loop? The loop is a closed path, starts and ends at the same node. Therefore, this starts from this I1 node, goes to the V1 node. After passing through the certain part of the graph, comes to the same node. Gain is nothing but this is a branch transmittance. So multiply this with this. So therefore, 1 by 1 over SC into minus 1 by R1. Now this is the gain of this is equal to 1 by S into SC into R1. The gain of the loop 1 is denoted by P11. This is the value. Similarly, gain of the loop 2. The gain of the loop 2 is denoted by is P2. The loop 2 is denoted by P22. Now what is the P22 value? P22 is equal to the gain of the loop 2 can be obtained by the gain of the loop 2 is equal to what is the value of gain of the loop 2 is equal to this branch transmittance. So 1 by R2 into minus 1 by SC. Therefore, what is the value of this? Is equal to 1 minus 1 by S into C into R2. The gain of the loop 2. Similarly, gain of the loop 3 is denoted by P33. The gain of loop 3. What is the loop 3? SCL into what is the value of this value is equal to S into minus 1 by R2. Therefore, here the final value is equal to SC into L divided by minus S into R divided by R2. This is the gain of the loop 3. Similarly, you have to identify if any loops are present, then you have to identify that loop also, calculate the gains. You have to name the loop gains are P11, P22, or P33. The next step, what is the value of, what is this step for calculating the transfer function? Next step is to calculate the non-touching loop. So non-touching gains product of the non-touching loop. So here L1 and L3 are the non-touching. Here L1, L2, L3. L1 and L2 is common node. V1 of S. L2 and L3 are common node. But L1 and L3 does not have the common node. The loops are said to be non-touching, does not have the common node. So that is what here L1 and L2, L3 is non-touching loop. So the next step we need to calculate the gains of the non-touching loops. Gains of the non-touching loop can be calculated in next step. In this particular step, I'm going for calculating gains product of the two non-touching loops. After observing from the graph, we go for finding the L1 and L3 are the non-touching combinations. L1 and L3 are non-touching loops. So therefore, we need to find out the gains product of the non-touching loops L1 and L3. The loop L1 and L3 are non-touching loops. So the gain product of the two non-touching loops are P13 can be calculated by the gains of this particular loop P11 and for this particular gains multiplied, then we will get the gains product of the non-touching loop. So after finding the gains product of the non-touching loop, so in the next step we go for finding the determinant of the graph. The determinant of the graph and delta K can be calculated in next step. In this particular step, I'm going for calculating the determinant of the graph. The determinant of the graph can be denoted by delta. Now, what is the value of delta? Delta is equal to 1 minus sum of individual loop gains plus sum of gains product of the all possible combinations of the two non-touching loops. Now, what is the value of, we have calculated this loop gains, individual loop gains, need to sum all the loop gains. So there are three loops. So the loop gains are P11 plus P22 plus P33. And also we have calculated gains product of two non-touching loops. The 1 and the 3 is a non-touching loop combinations. Therefore, we go for already calculated in previous steps gains product. So that is indicated by P13 is a gain product of the L1 and L3. Now after substituting, then we will get the delta value. Similarly, what is the value of delta K? The delta K is nothing but the, here delta K is equal to part of the graph. It can be calculated by considering the part of the graph which is not touching to the first forward path, but here all the part of the graph which is touching to the first forward path. Therefore, first forward path. Therefore, there is here the delta K. There is a delta K is equal to 1 because K is equal to number of forward path is equal to only 1. Therefore, the delta 1 value is equal to 1. This can be calculated by using the same formula for delta. What is delta? Is equal to 1 minus sum of individuals gain is 0. Therefore, delta 1 only because there is only one forward path. There is only one delta 1. Therefore, delta 1 value is equal to 1. Now, the delta 1 when we calculated by considering the part of the graph which is not touching to the first forward path. So, therefore, K is equal to 1 ಇದೆ. Therefore, delta 1 ಮಾತ್ರ calculate ಮಾಡಬೇಕು. And by considering the part of the graph which is not touching to the first forward path. So, the first forward path ಎಲ್ಲ part touch ಆಗ್ತಾ ಇದೆ. Therefore, no need to calculate that is what delta 1 is equal to 1 minus 0. Sum of individual lobe gains are 0 and also gains product also 0. Therefore, delta 1 is equal to 1. No. In the next step, we go for substituting these values. Delta 1, P1, we have calculated in previous earlier step. So by substituting this value, we will get the overall gain V naught of S and VA of S in next step. In this particular step, we go for calculating the overall gain by substituting the various values. By substituting P1, delta 1, and delta, we will get the overall gain of the system. This is the procedure for converting. This is the we go for calculating the overall gain of a system if the electrical network is given. The electrical network is given. Need to convert the electrical network into the signal flow graph. Then by applying the Mason's-King formula, we can gain the overall gain of the system. In the next session, I'm going to discuss regarding how to calculate the overall gain of the system. See if the overall gain of the system. If some algebraic equations are given, then how to construct the signal flow graph and how to find the overall gain or transfer function of the system in next session. Therefore, I'm going to discuss in next session. Thank you for listening.